Hello everyone and welcome back to the channel LessonUP with Sugandha, and I am really happy to be here back again. I am really getting good response. So as I promised in the earlier video that I am going to make a separate dedicated video upon balancing chemical equations, and so here it is. And I also promise by the end of this video you will no longer be at the beginner level of balancing a chemical equation, but I believe so that you might just become a pro at it and might just be able to teach others. So let's begin. Right. So first of all, before even we start understanding how to balance a chemical equation, I have one example about an equation which goes like this, right? So on the screen we have this word equation which says hydrogen gas and chlorine gas combine to form hydrochloric acid, right? We all know. But imagine if we had to write every equation in the word form, it will take a lot of time, and sometimes we might just end up with spelling errors. So just to avoid that, we came out with a very good solution of giving them symbols form and writing the equations then, right? So chemistry uses a lot of equations, symbolic equations, and so I'm just going to do the same. I'm going to write hydrogen gas, my and gets converted to a plus sign, chlorine gas here, and combined to form will become an arrow, and hydrochloric acid, right? Let's look at it closely now. So while I have these uh, reactants and products on the left and right side of the arrow, do you think it is balanced? Right, we can't move on with the chemical part of this equation if we can't really use it, neither can we proceed with any calculations if this is an unbalanced equation. We need to balance it, right? So what is actually a balanced equation? We need to have same number of atoms on both sides of the arrow. This is the simplest way that we can break down our chemical equation or a balancing equation into, right? So I'm going to just highlight same number of atoms on both the sides of the arrow, right? So keeping this in mind, what am I supposed to do is just going to show you pictorially so that you understand better. I'm also a visual learner. I hope this helps better. So let's have a look at this. So I have two hydrogen atoms with me. I have two chlorine atoms with me, and if I want to make this hydrochloric acid, I have one H and one Cl, right? So the definition says same number of atoms on both the sides. Now if I look here on the reactant side, I have 1 and 1 2 H molecules, 1 and 1 2 Cl molecules, but here I have 1 and 1 both of each H and Cl molecules. Is it a balanced equation, right? No, it's not, because we have two hydrogen molecules, two chlorine atoms on the left hand side, but on the right hand side we have one molecule of HCl, right? We need to make it balanced. How can I do so? I can maybe bring in some hydrogen molecules here, or maybe some chlorine molecules here, or maybe another molecule of HCl here. But how will I do that? How will I get to reach the point where both of these sides are balanced, right? If I can just bring about one HCl molecule here, let's see then what happens. So now if I get down to, so this number changes, right? There are two here, two here. So on the left hand side I have 2H2, my H2 is balanced, and two molecules of chlorine, two molecules of chlorine, balanced, right? So my definition of a balanced equation fulfills here. I have same number of atoms on both the sides of the arrow, right? So now let us look at another equation, right? This is again a word equation. We are going to write it in a symbolic form. Hydrogen gas and oxygen gas combine to form water, right? Okay, so again I'm going to run towards making the molecules, and let's take it yellow. Okay, and now what will I have? As it says, I have two hydrogen molecules and one oxygen, right? So let's count on the reactant and the product side. I have two hydrogens here, two oxygens here, two hydrogens, and one oxygen. Is it a balanced equation? Definitely not, right? Because we have two here. Okay, hydrogen is balanced, but is our oxygen balanced? We have two here and just one here. What can we do here, right? So what can we do here? If I now bring another molecule of water, so I'm writing 2 here, and I am bringing up another molecule of water like this. So now what happens to the reactants side? My hydrogens are all right, 1 2 3 4 now, and my oxygen are 2 here. And since here my oxygen is balanced, thankfully, now I'm going to go back to my hydrogen. Is it balanced? No, I have 4 here on the product side, 2 on the reactant side. I might just add up 2 here. That brings us to a balanced equation. Let's look. 4 4 2 2. So this is a balanced equation proving the statement same number of atoms on both the sides of the arrow. Let's have a look at another example. Iron and oxygen combine to form iron oxide, right? So how do we write it as? Iron and oxygen combine to form iron oxide. Simple, right? So what do we have? Iron. We have 2 here already. And we have this and this, right? So what could we do? Do we need to disturb our Fe here? We have one here, sorry, 2 here, but 1 here, right? So we need to do something about the oxygen part. So let's try to bring up another molecule of iron oxide here, here. So now what happens? My iron becomes 2 molecules and oxygen gets balanced. What can I do now? Simple. Reactants and products are absolutely balanced, right? So now let us have a look at some of the examples. So to better understand and move on to the practical part of how to balance it out, we can't always use the diagrammatic representation, right? It was just for your understanding. So here we are going to write it in tabular form so that whenever you are solving an equation, it just speeds up your process a little faster. So what are we going to do here? We're going to have a partition, right? Or you may just skip the partition as well. We are going to write I have hydrogen, bromine, H and Br. Try to write it in the same line so that it makes your task a lot easier, right? So how many of hydrogens do we have on the reactant side? 2, and here 1. Br again 2, Br 1. So what can I do here? I might just simply bring a 2 here, which makes my hydrogen 2 and bromine 2. So counter checking, hydrogen balanced, Br balanced. Let's have a look at another example. H C O. H C O. We have a lot of oxygen here, so we need to keep that in mind and also try to solve it at towards the end part, right? So that maximum of the balancing part has happened already. So during that process, we might just end up balancing oxygen already, right? So that is why whenever we see an equation with a lot of uh, H and O's, we try to keep them towards the end so that during the process of balancing, they just might balance themselves, right? Okay, so hydrogen, how many do we have here? 2 on the reactant side and 2 on the product side, balanced already. C, we have 1 here and 1 here. Now O, we have 3 here and 3 here. Oh, we have a balanced equation already. Okay, 2, 1, 3. Okay, great, right? So we need not balance, we need not do anything here. It's already balanced. Let's have a look at another example. A partition Ca, Ca, H, H, O and O, right? This H repeats here. Before I dive into the balancing of this equation, let me just tell you some important part. Whenever we see a parenthesis here, these parentheses always apply to the entire numeric value that has been written here, right? The subscript will be multiplied to everything that is inside. By everything I mean everything, right? So this 2 will apply to this O and this 2 will apply to this H as well. So while counting, we'll get to understand this better. So Ca on the reactant side, I have 1, product side thankfully 1, H I have 2 here and H I have into, this is 2 and plus the 2 already, which makes it 4, right? Oxygen 1, oh sorry, oxygen 1 here and oxygen 2 here, right? So we need to do something about our H and O, and always you have to go try to fill in a number where it is less, right? So we have the H and O's less on the reactant side. We're going to try fix it up here, right? So let's start by writing a 2 here. So now my H becomes 2 into 2, 4, and my O becomes 1 into 2, 2. So yes, it is balanced now. Ca 1 1, H 4 and 4, O 2 and 2. Balanced again. And the last equation now. Differentiation, right? Na, Na, Br, Br, Cl, Cl. Okay. So how many molecules? 1, 1, Br1 or Br2, Cl2 and Cl1, right? So our Na is balanced. Let's have a look at Br. So Br is less here, Cl2 is more here. Okay, I might just move to increasing this here. So this means my Na is disturbed to 2, my Br is balanced to 2. Okay, to balance my Na as well, I'm going to shift it up here. So that makes my Na2 and Cl2. So now gathering up the addition part, Na, Na, Br, Br, Cl, Cl. This is also is balanced, right? This was some of the these are some of the methods that you can use up, and I hope that you've become a pro at solving the chemical equations better, right? So go out there, uh, practice, 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 get yourself to understanding better, and see you in the next class, right? Thank you.